Today we're going to be factoring polynomials completely. All right, so first on here you've got your state standards and then your success criteria. So to be successful, you need to be able to factor polynomials by grouping. We have briefly looked at this, so hopefully this is not completely new today. You need to be able to factor polynomials completely. So you may factor, but within that factor, the result may have binomials or trinomials that can be factored further. So when it says factor polynomials completely, you've always got to check that last step to make sure you can't go a step further. You need to be able to solve real-life problems by factoring. All right, a couple vocab terms that you need to know. Make sure these are in your notes. Factor by grouping. To factor a polynomial with 4 terms, group the terms into pairs. Factor the GCF out of each pair of terms. Look for the factor out of the common binomial factor. Factored completely. A factorable polynomial with integer coefficients is factored completely when it is written as a product of unfactorable polynomials with integer coefficients. So it's factored completely when the product is everything is unfactorable. So when you get to the last step, if everything in that last step is unfactorable, then you know you have factored it completely. A couple key ideas that you need to be familiar with. Again, factoring by grouping. To factor a polynomial with 4 terms, group the terms into pairs. Factor the GCF out of the pair terms. Look for and factor out the common binomial factor. This process is called factoring by grouping. Your concept summary, guidelines for factoring polynomials completely. To factor a polynomial completely, you should try each of these steps. First, always try to factor out the greatest common monomial. Okay, so always try to find your greatest common factor first. Then look for a difference of 2 squares. Factor a trinomial of the form ax squared plus bx plus c into a product of binomial factors. And then always factor a polynomial with 4 terms by grouping. So these are different things that you can do. Sometimes you may have to use more than one of these on a problem to get to the end to where it is completely factored. All right, let's look at example 1. Factor each polynomial by grouping. All right, so it tells us to factor by grouping, but if you look at a polynomial and you see that it has 4 terms, hopefully you automatically think grouping. All right, so 4 terms, I'm going to group these into 2 terms each, and then I can factor out my greatest common factor of each binomial. So x cubed plus 3x squared. I can factor an x squared out of both of those. If I pull an x squared out of x cubed, I'm left with x. Remember, properties of exponents, same base, you add exponents. So x squared times x to the first is x cubed. And factoring is just the process of rewriting something in factored form. So you want it to be equivalent to what you start with. All right, so if I have 3x squared and I factor out x squared, I'm left with plus 3. All right, then I had plus 2x plus 6, so I'm going to factor out a plus 2. And if I factor out a 2, I'm left with x. 2 times 3 is 6. And so now I have factored both binomials. Now I can see that my greatest common factor here is the binomial x plus 3. So I have x plus 3. And then I'm going to put my x squared with my plus 2. And I am done. So this is completely factored. All right, B part, we're going to do the same thing. All right. I've got x squared plus y. X squared plus y, there's nothing to factor there, so I'm going to rewrite this first. Let me come back up here. I need to rewrite it to where there is something in common beside of each other. So let's rewrite this as x squared plus x plus y plus xy. So you can see that all I did was rearrange the terms in the middle. It doesn't change anything, but now it allows me to factor in x out of my first binomial. So factor in x out, and I'm left with x plus 1. In the second binomial, I can factor out a y, and I'm left with 1 plus x. All right, so x plus 1 and 1 plus x, that's the same thing. So I've got x plus 1, and then I've got x plus y as my other binomial. You can always check this. X times x is x squared. X times y is xy, which is on the end. 1 times x is x, and 1 times y is y. So this is factored form. All right, C part says 3p cubed minus 30 minus 5p squared plus 18p. So I don't have to put this in standard form first, but I'm going to. So I'm going to put this in standard form. So I'm going to do 3p cubed minus 5p squared plus 18p, and then minus minus 30. Well, all right, there we go. All right, so I've got 3p cubed minus 5p squared grouped together with parentheses now. So I'm going to factor out my p squared. And I'm going to be left with 3p minus 5. All right, then I have plus 18p minus 30. 18 and 30 are both divisible by 6. They're also divisible by 2 and 3, but you always want to find your greatest common factor to make sure you're factoring completely. So I'm going to factor out my 6. 6 goes into 18, 3p times, and 6 goes into 30, or negative 30 minus 5 times. This is now my greatest common factor, so 3p minus 5 comes down, and p squared minus 6. Now, if this 6 were a perfect square, you would be able to factor this further as a difference of squares, but 6 is not a perfect square, so this is now factored completely. All right, take a couple minutes, do the self-assessment. Go ahead and pause the video. When you're ready to resume, just press play and check your answers. All right, hopefully you took time to work on this by yourself. So let's see how you did. All right, A part says writing. Explain how to choose which terms to group together when factoring by grouping. All right, so if you remember, I started with B part to just put parentheses around it and try to group it and do that. But then I noticed that the second term was a Y, so there was nothing I could factor out if I did not rearrange the terms first. So what I did was make sure that when I rearranged it, that the two first terms had something in common, and then the two second, the third, and fourth term also had something in common. So if you do that, there's no specific way you have to group it. Just make sure that there's something factorable when you do that. So you want to be able to factor out your greatest common factor. So for B part, where it says y squared plus 2x, since these terms don't have anything in common, you could rearrange it and you could either put the yx as the second term or the 2y as the second term. It doesn't matter. But since both of the middle terms have an x, I would move the 2y over next to the y squared and factor out the y. That's me. That's not the only way you could do it, but that may be the best way for that one. All right, C part in example 1b, can you group the first term, x squared, with the fourth term, xy, and then factor? And the answer is yes, because if you did that, you could still pull out an x, which is your greatest common factor, and then you would still get the same factors in the end as the final result. All right, example 2, factor completely. All right, if I look at A part, I've got 3x cubed plus 6x squared minus 18x. The first thing I notice is those are all divisible by 3. Again, you need to have a good number sense. If you can multiply well, That means you can divide well, and that means you can find your greatest common factor quickly and easily. They all also have an x in common. So my greatest common factor here is going to be 3x. So the first thing I need to do is factor out a 3x. 3x times what gives me 3x cubed, and that would be an x squared. All right, 3x times what gives me 6x squared, and that would be a 2x. And then 3 goes into negative 18, negative 6 times. And since you factored out the only x, there's no variable on the end. All right, so what I want to do here is see if I can factor this into two binomials. So I'm going to have 3x. And let's see if I can factor this further. So I'm going to have x times x. So I need to see what multiplies to give me negative 6 and adds to give me 2. So I've got 1 and 6, 2 and 3. 1 and 6 will not give me a 2. 2 and 3 also will not give me a 2. So this term here is considered unfactorable. So when I get to the first step, I should always check to see if it will factor further. But in this case, the first step is as far as you can go. So factored form would be 3x times x squared plus 2x minus 6. All right, 7x to the fourth minus 28x squared. Hopefully you know that 7 goes into both 7 and 28. So I can pull a 7 out of both terms. Also, x to the fourth and x squared. I can factor out an x squared from both terms as well. All right, so 7x squared from 7x to the fourth leaves an x squared. And 7x squared from 28, negative 28, would be negative 4. Since I factored out the x squared, there will be no variables there. All right, now perfect square minus a perfect square. Hopefully you recognize this is a difference of squares. So bring down my 7x squared. Remember, a difference of squares is x plus 2 and x minus 2. Same binomial, different sign in the middle. All right, if you want to check, you can always check. X times x is x squared. Minus 2x plus 2x cancels the middle term. 2 times negative 2 is negative 4. And then I'll take this and multiply it back in, and I get what I started with. All right, the last one, m cubed minus 2m squared minus 8m. I can factor an m out, and that's it. And I factor an m out, I'm left with m squared minus 2m minus 8. Again, I want to see if I can factor this further. All right, so let's see. I've got negative 8. 8 is 1 and 8, or 2 and 4. 2 and 4 could give me a negative in the middle. When I multiply to get a negative 8, I know I've got to have opposite signs. If I have a negative 2, I need my bigger number to be negative. So plus 2 minus 4. So I'm going to have m plus 2 minus 4. Again, you can quickly check this. M times m is m squared. Minus 4m plus 2m is negative 2m in the middle. 2 times negative 4 is negative 8. Multiply all three terms by m, and you get what you started with. So that is my completely factored form.